Just make sure you wipe down the area before you use it. You did? Okay. Just wipe down the area. As long as it's done, you're good. Right. So let's go ahead and take roll. What's Johnny? Not here. DeAndre. Aliana. James. Caius. Not here. Sarah. Devon. Excellent. So, I understand y'all had a test yesterday with Miss Lamar. How'd that go?
Good.
Excellent. Good to hear it. That's kind of what I've been hearing from everybody today. So, I hope everyone actually gets good grades on that. From what I've seen so far, it looks like, yeah, we did pretty well on it. So last time that we had a lecture, we were talking about graphs and how graphs help us visualize data because we are very visual creatures. We don't understand numbers as well as we do graphs and visual things. So, for instance, if we had a frequency distribution, something simple, let's say color of the t-shirt in class. Red, green, blue, and yellow. So these would be our scores. We can also call this our class. Each one of these would be classes. Okay? And then, of course, what we do with our frequency distribution is we count up the number of times we see each of these things happening. So, for instance, if 5 people wear a red shirt, that's 5. Same thing for green. 3 people wear a green shirt, it's 3. And we can fill in the rest of this that way. These are our frequencies. So again, a frequency distribution has classes and frequencies, and these frequencies just fall into whatever category we have. This is what kind of data though? Qualitative or quantitative? These right here, is this qualitative or quantitative? Qualitative, because these are qualities that we're measuring. Okay? So one useful graph that we have for things that are qualitative is the bar graph. So I'll make a quick bar graph down here for us. So the first thing we need is our classes. These are our independent variables. These are not going to change based on other outside changes. They're always going to be these colors. So we can put these on our horizontal axis. This is where we usually put our independent variables. So I'll put R, G, B, Y here. Okay? Now the other thing we need is we need a scale for our frequency, and that is going to be our dependent variable. So that's the vertical here. Okay, so I'll start at 0 and work my way up to 5. So 0, 1, 2, 3, 4, 5 is right there. And now it's just a matter of putting our bars in there, counting how many we have on our frequency and putting it down there with our scale. So for instance, red, there's 5 in our frequency. So here's 5. So there's our red bar. Green, we have 3 of them. So there's 3. There's our green bar. Blue is 7. Oops, should have put more in here. 5, 6, 7. So there's our blue. And then yellow, we only had 2, so it's all the way down here. And again, what this graph allows us to do is to look at our data at a glance and sort of understand what it looks like instead of having to just look at numbers. Again, our brains aren't really great at numbers. They're much better at visual things, so shape and size. So this is how we would arrange qualitative data. When we get into quantitative data, things start to change a little bit. So the first thing I want you to notice about this that we're going to see is a little bit different with quantitative data, is that these are discrete. So there's an idea here, discrete versus continuous. That is not how you spell discrete at all. Oh my gosh. There we go. There we go. So discrete versus continuous data. Discrete means that it falls into very specific categories, like red, green, blue, yellow. These are all discrete. Okay? Another way to think about it is that there's nothing between red and green. It's just, are you red or are you green? You know, you can't have red-green in this kind of data. There's not a bunch of different things between these two classes. Now, with quantitative data, you have to remember that quantitative is talking about numbers. Numbers are all on a number line. And you can have 1 or 2, but you can also have things like 1.5. We have things in between these things. So this is continuous. Okay, so discrete, we have very specific things, very specific classes that these frequencies fall into. With continuous, they're not as specific. Instead, what we're going to have are ranges that we put our data into. So any questions so far? All right, so let's go ahead and take a look at some quantitative data. Okay. So let's say that we've gathered some data. Hours of time spent on homework each week. Okay? So we've polled a class. We know how much time they spend each week doing homework. Now, if our data looks something like, I don't know, 8, 7, 12, 20, 34, 45. If this is what our data looks like, we could make a class for each one of these, but each class would just have one data point in it. It wouldn't be very useful to us. Maybe you get lucky and you have a mode. Of course, not all data has a mode, but oh, that one has 2 now. Well, it's not going to show you anything except for which one is got a mode. So we can't just make a class for each one of these numbers. We can't just file in 8, 7, 12, 20, 34, and 45, especially because this data is continuous. There could be people who have 7.2 hours each week. There could be people who have 12.5 hours each week. So we have to not only account for the fact that, well, if we just did these as classes, it wouldn't tell us much, but also But there are people between these that we need to be able to fit into our data. Okay? So, we again have classes, but these classes get broken up a little bit differently. Instead of being very specific things like red, green, blue, yellow, they're ranges of numbers. So I'll just copy down the ranges that I have here: 8 to 15, 16 to 23, 24 to 31, 32 to 39, and 40 to 47. Okay? And by the way, this data, I just made this up. We don't need that. This is just an example. But let's say that we look at the real data and we get some frequencies. So maybe we have something like 8.5. Well, it would fall in this first class. We mark down a frequency for that. And we would count up all these. So maybe like we have one that's 34. Well, 34 falls in this range right here. So we'd have a frequency there. And so we count up all these things and sort them out into these ranges. And we get 11, 10, maybe 7, maybe this one has 3, and 12. Okay, I'm just making these numbers up. But again, after we look at the data, maybe we see, okay, there's 11 people who fall in here, there's 10 people who fall in here, there's 7 people who fall in here, and so on and so forth. These ranges give equal representation to all of our data points. Again, if we were to just say, all right, each of these numbers gets their own class, again, each one of them is only going to have 1 or 2 frequency in their class. But by making ranges like this, we allow all the data to be represented equally. Does that make sense? Okay, something that's important about that equality when we're showing our data, by the way, is our class width. Class width is how much space there is for a class. So the way you calculate that is you take this number, this lowest range right here, so the low range on this one is 8, and we subtract it from the low range of the next class. So to get the width of this one, we take this low range, subtract it from the low range of the next one. So what's 16 minus 8? 8. So the width of this class is 8. Let's do the same thing for this one. Let's calculate the width for this one. So we take the low range, subtract it from the low range of the next one. So 24 minus 16, what's the width on this one? 8. And in fact, if you do that for all of these, you'll see that all of these have a width of 8. And that's important. All of these classes need to have the exact same width. Otherwise, you'll have classes that are really wide, and they'll swallow up all of your data, or you'll have classes that are really thin, and they won't have hardly any data in it at all. But if they're all evenly spaced, then again, the data gets equal representation. Any questions? Nothing so far? All right. So from this point, again, frequency distributions are a great start for organizing our data. But like I said before, visuals are always the best way to present data to somebody. So let's go ahead and make a bar graph for this one. Okay, so again, I have classes here. So my first class goes from 8 to 15. And because this is continuous data, I want to actually call my classes their widths. So 8 to 15 is this class right here. Then we have 23, then 31, then 39, and 47. So notice that these things bump up right against each other. So my first class, 8 to 15, bumps up right against 16 to 23. There's no space between it, and that's because this is continuous data. We want to represent everything on this number line. Alright, so there's our classes. Now we need our frequency. So scale for our frequency. Well, the lowest number we have here is 3, and the highest number we have is 12. So we can probably go ahead and start at 0 and then go to 12. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Whew. Excuse me. Okay. So now, just like we did before with our qualitative data, we're just going to look at our frequencies and make bars for our quantitative data. So let's see. Our first one, our first class, 8 to 15, had 11 points in it. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 is right there. So our bar will go to there. Again, the next section is going to butt right up against it. So 10 for the second one, that's 10 is right there, bumps right up against the previous bar. There we go. And keep doing this. So that's 10, 9, 8, 7 is right there. So make our bar. 3 is here. And then 12 is all the way up at the top. Okay, so here is our quote-unquote bar graph. Now this actually isn't a bar graph. It looks a lot like one, but there's another name for this one. This is called a histogram. Again, a histogram. So what this does that's different from this qualitative data is that there's no kind of order to qualitative data. Or, well, at least not this one. It's not ordinal, it's nominal. Okay? This one is absolutely ordinal. We have values. These frequencies are ordinal. Okay? So these ordinal frequencies arranged like this with this quantitative data, ordinal quantitative, means that this is arranged from least to greatest in 2 ways. So we can start making some interesting conclusions about this. First of all, notice how if we were to draw an imaginary line across the tops of these, we get this curve. And I should have made this go all the way down here. We get this curve. So what we can infer from this is, okay, well, this right here, 8 to 15 hours, is kind of the lower end of our class or our homework time. You know, these people are only spending 8 to 15 hours. It's the lower end. And then as we go this direction on our horizontal axis, this is increasing amount of time worked on homework. So we can see as we go through here, what's going on with the amount of people. It's dropping. So we can say, okay, not a lot of people work on their homework for that long, but as we continue, fewer and fewer and fewer people work for that long on their homework until we get to here. So we have like two types of students. Normal students, this is what you can expect to see. You know, you'll have a lot of people that don't spend a lot of time on homework, and then as you slowly increase the amount of time to spend on homework, fewer and fewer people spend that amount of time. Then it jumps up and we have a separate type of student. It's like an overachiever. So 12 people in this class spend 39 to 47 hours a week on homework. That's a lot of time. So we can then use this graph to start thinking about how, you know, students work on their homework. What could be changed about the classroom? What could we do to maybe increase the amount of people working on homework or decrease the time that they have to use to work on their homework? So these histograms show us these really nice curves. Now a lot of times when you see a histogram, the bars are going to do this sort of thing. So if we look at the curve of this one, this is what we call a bell curve. So I just draw it out like this. It's called a bell curve because it kind of looks like a bell a little bit. Okay? But a lot of histograms are going to do this. What we're doing with this data is we're seeing where it piles up. So we have two places that this piles up. Not a lot of time spent on homework and a lot of time spent on homework. The one place that it doesn't pile up is a middle amount of time spent on homework. Either people don't spend any time at all or they spend a lot of time. Okay? If we were to look at grades on a test, it would typically look something like this. You have a few people who do really bad, a few people who do really good, and then a lot of people who do, you know, like 70 or something like that. It's midway through. Okay? So this is what you can expect to see with this type of data, with this quantitative data. You'll start to see trends. That's why these histograms are so nice, because you can see trends. Like again, like I saw, the trend here is that either people spend very little time or a lot of time. There's no middle ground really. It's a little time or a lot of time. That's the trend. Any questions? Okay. There's one more thing I want to show you all today. Let's say we have another one of these frequency distributions for quantitative data. So I've got classes 20 to 23, 24 to 27, 28 to 31, 32 to 35, and 36 to 39. First of all, what is the class width for each of these classes? Four. Yeah, again, what you do is you take this number and subtract it from the next low end of your class, the low end of the next class. So 20, subtract that from 24, we get 4. Same thing if you did 28, subtract that from 32, we get 4. So the class width for each of these is 4. Okay, and let's fill in some frequencies as well. Let's say we have 12 in the first one, 9, and 14, 3, and 11. Which one? This? That's a 14. Okay, what do we say it's a good idea to do with our frequencies once we have them? What should we do with these now that we have these frequencies? Add them up and get the total, yeah. So that's always a good idea. So let's go ahead and do that. So 12 plus 9 plus 14 plus 3 plus 11 gives us 49. Okay, now I'm about to add a new column.
Relative?
Not relative, cumulative. For these? So cumulative frequency is a running total. So we can do just a general total on these, but a running total will allow us to tell how much data is above or below a certain class. Okay, so what we do for this is we say, all right, how many do we have in total so far? If we just look at this class. 12. All right, now we have 2 classes. So how many do we have in total so far? 21. All right, keep doing that. So how many do we have now in total? 35. Now? And now? 49, which makes sense because our total frequency is 49. Again, what this allows us to do is tell how many points are above or below. So like this class right here, we can see that there's 21 data points above this class. And we can make a percentage out of that. 21 divided by 49, what would that be? 21 divided by 49 is 0.43, so 43% of the data is in these 2 classes. We could say is above this class right here. That's already a lot of our data. We could do the same thing with this. 35. 35 data points are above this class. So they're up there. So let's see what percent is above this class. So 38 divided by 49 is 0.78. So 78% of the data falls in these 3 classes above this one. And you can keep adding all these up, and eventually you'll get 100%. After all, 49 divided by 49 is 1. 1 as a percent is 100. So we can then do that. So 12 divided by 49 is 2.3, which I'll just make as a percent. So 23% of the data is in this class, just alone. Then 21 divided by 49, we have 43% is in these 2 classes. 35 divided by 49 is 71. So 71% of the data is in these 3 classes. Then 38 divided by 49 is 78. So 78% is in these 4 classes, and then 49 divided by 49 is 1. We get 100% in all the classes. Okay? Again, this is useful because it lets us see how much data is where. And like I was saying before, when we get to things like these bell curves, knowing where our classes are and how much data is where helps us normalize these bell curves. So we can say, all right, we can take this slice and we'll know exactly how much of our data is in that slice. Maybe, I don't know, 43% is in this one. And actually, I'll just make this like this. So we could say that 43% of our data is in this shaded area. That then gives us a probability. We can say, all right, if this is the amount of time that students work on homework, then we can say 43% of our students work under 28 hours. So 43% of the students work under 28 hours in the week on homework. So we can get probabilities now. If we were to just select one of those students at random, there's a 43% chance that they are in this category right here. They work below 28 hours on homework a week. Does that make sense? Okay. So that's what these cumulative frequencies are for. They're these running totals that allow us to do things like this. Any questions? None? Okay. Then I think that will do it for today. So, I hope y'all have a good weekend, and I will see you on Monday when we start a new section.
New section.